Hello everyone. Today we are going to discuss about that abstraction. Here in the object-oriented programming language, we are having the four pillars of OOPS: encapsulation, abstraction, polymorphism, and inheritance. Out of these four pillars, we are having the one most important concept, that is the abstraction. Here, abstraction means it is the process of hiding the implementation and showing only essential features into the end users. Here, we are hiding the unnecessary data into the user, which are necessary. We are only showing those data into the end users. Here, to achieve the goal of abstraction, we are having the two possibilities. One is abstract, and one more is considered as a interface concept here. And currently within this class, we are discussing about there is an abstract keyword. Here, this abstract keyword can be implemented with method, and this abstract keyword can be used with class also. Here, for example, when we need to implement that abstract keyword, currently if you are having the one class, here it is a class vehicle. Means we are having the one vehicle class. Within this vehicle class, if you are having the function, for example, public wide, here this one is a public wide, and number of wheels. For example, we are having the one function. Suppose if this function is returning some value here, for example, if you are returning here some value, maybe that value is considered as an integer type of the data. Here, once you implement that vehicle class, we can return the one integer value here. Currently, we are having the vehicle. Once you implement that number of wheels, we don't know about that particular returning value here, because number of wheels will be defined based on the type of the vehicle. For example, if you consider vehicle as a bike, then directly you can return the 2 here. Suppose if you consider vehicle as a car, then directly you can return the 4. Means that number of wheels will be defined based on the type of the vehicle. Currently, we don't know about that particular vehicle. In that situation, we can define this method as a abstract here. Means we are not implementing any logic. If you're not implementing any logic here, then this statement should be end with a semicolon. And this method should be declared as a abstract. Here, abstract method means which method does not have any body. That method is considered as a abstract method. You can consider one more class. For example, here it is a class. Fruit is our class. Here it is a fruit is our class. And within this class, we are creating the one function. Here it is public. Return type is string, and we are returning the taste of the fruit. Here, currently, if you are having some logic, suppose from this particular function, we are returning the some value here. To define that taste, first we should know about that fruit here. Currently, we don't know about that fruit because if you consider mango, we're having the one type the taste here. If you consider apple, if you consider as another type the taste, means that taste will be depends on the type of the fruit. So if you're not aware of that particular logic, in that situation, we can define that method as the abstract method. Here, directly, you can define this method as a abstract method. To define that, end with a semicolon and add one keyword here, that is a abstract keyword. Here, once you define this method as a abstract, that class should be defined as a abstract class here. Currently, this class is considered as a non-abstract class. This one is a normal class. Here, once you define any method within the one class, so that is the abstract function, then that class should be considered as a abstract class here. Means defined as a abstract class. Here, vehicle class and fruit class should be defined as a abstract class here. And suppose within this function, you can create one more type of function here. For example, public void m1 is a function. For example, just we are creating the one function, and this function is having the some body, means it's considered as a some logic here. In the abstract class, we can define both the types of the functions. Means within the single class, if it is abstract class, within that class, we can define both the types of the functions, abstract method as well as a non-abstract method. Here, number of will be considered as a abstract function. M1 will be considered as a non-abstract function. Here, from this particular abstract keyword, we can achieve the goal of abstraction, that is a 0 to 100% abstraction. What's the meaning of abstraction here? Means within the vehicle class, currently we are having the two functions here. One function is abstract, another one is non-abstract. Then vehicle class is achieving the goal of abstraction, that's only 50%, because one is abstract, another one is a non-abstract. Then suppose if you consider fruit class, here fruit class having the only abstract function, then that class is achieving the goal of abstraction, that's 100% abstraction. That's a 100% abstraction. Suppose if you are removing this particular abstract function from the vehicle class, then vehicle class achieving the goal of abstraction, there's only 0% of abstraction here, because it's having only one function, that's a non-abstract functions. Here, abstraction can be achieved within the abstract class, that is 0 to 100% abstraction. Then the abstract class should not instantiate, means we're not able to create the object for this particular vehicle class as well as a fruit class. Means if any class defined as a abstract class, we should not able to create a object for that particular class here. Means object, that's an instantiation. Abstract class doesn't instantiate. In that position, within the vehicle class, we are having one abstract function. For that abstract function, we need to provide the implementation only within the child class. For example, if you are creating the one class, here is a class bike. Within the bike class, you can provide the implementation for this particular number of wheels function. Here it is. This one is the non-abstract function, and within this particular second class, we can provide the implementation. Means bike is considered as a normal class, not abstract class. Here, bike class is considered as a child class, and that bike is accessing the properties from the one parent class, that is a vehicle class. Here, vehicle is a parent class and bike is considered as a child class. Once you implement this particular is a relationship, that's an inheritance relationship, then that child class should be provide the implementation for all the methods of the parent class if those are the abstract. For example, currently vehicle class having only one function, that's the number of wheels is abstract. Suppose if you are having the one more abstract function, then within the bike class you should provide the implementation for both the functions here. That's a mandatory. Within the bike class, you should provide the implementation for all the abstract method which are defined within the parent class. And directly you can create the object for this particular class. Here it is a child class. For example, this one is a class test. Here within the test class, we are creating the main method. Here it is public static void main. And within the main method, we are passing some arguments. Then within the main function, we are creating the object for the bike. B is equals to new bike. And if you want to call that function b dot number of wheels, then directly it will return something value here. For example, this one is return. Here it is a 2. And that returned value will be stored within this particular statement. For example, system dot out dot print ln. Just we are printing that result. Here, that return value will be displayed into this particular statement. Suppose if you are having one more class, for example, car is a one class, that's again child class, accessing the properties from the again vehicle class. Number of wheels can be defined within the car class also. Means car class accessing the properties from the again vehicle class. And that car class can return the some value. For example, here it's a 4. In that position, you can define those methods with the abstract class. Here, in this class, we're having the abstract function. Suppose if you remove this particular function, there's a number of wheels defined as an abstract. If you remove this particular statement, still this program will be executed. Then what is the use of that abstract method here? Because within the child class only we are defining those methods. And within that subclass, normally the programs will be executed. Here, this one is not a with semicolon and normally executing that particular statement. Suppose if you want to execute or implement mandatory fault within the child class, suppose if you want to define that mandatory part means you must execute something within the child class. Suppose parent is considered as a vehicle class, bike is considered as a child class. Within the bike class, we must execute something. In that position, you can define that method within the parent class. Means once you define any method as an abstract, within the child class, you must provide the implementation for that particular abstract keyword. This one is related to abstract keyword. And with the help of that abstract keyword, we can achieve the goal of here it is a abstraction. We are hiding the necessary, unnecessary informations into out of the world. Differently, within this application, we are hiding this particular logic. We are only showing the vehicle class into end users. Within the bike class, we are having that logic, but into end users, just we are displaying the number of vehicles which are necessary into the end users. We are only showing those informations. Here, background logic not needed by the end users. In that position, we can implement the abstraction concept here.